जो सफर की शुरुआत करते हैं वो मंजिल को पार करते हैं। बस एक बार चलने का हौसला रखिए। अच्छे अच्छे इंसान का तो रास्ते पे इंतजार करते हैं। गुड मॉर्निंग, नमस्ते टू ऑल dignitaries, principal, vice principal, HODs and staff members of Modern College. With great joy and immense exultation, myself, Janvi Sukhwani, with my co-anchor,
Navin Kunde,
we welcome you all
on behalf of Modern College of Art, Science and Commerce.
We feel privileged to extend a warm welcome to all presented here for inauguration of lecture series in geography on the theme Advanced Techniques in Geography. The essence of great leadership is influence and not authority. With this note, I would like to welcome the respected Principal Sir, Dr. R.N. Sunzal Rao, and the Head of Geography Department, Dr. Vilas Kamble Sir, to this function. Stars shine at night. Some stars shine at bright daylight. It's our pleasure to welcome one such star, Dr. Sudhakar Pradeshi Sir, the Honorable Chief Guest of today's function. Last but not least, I sincerely invite and welcome all my student friends. You are strong and smart. Once again, I welcome everyone to the inauguration event and guest talk.
When darkness comes, let us not all condemn the dark, but light a lamp to illuminate our paths. Now, I would like to request our respected chief guest, Dr. Sudhakar Pardeshi sir, to come up on the stage and inaugurate the program by lighting the lamp of hope, courage, and knowledge. Please, sir. Thank you, sir. Thank you, sir. Thank you so much, sir.
So let us begin with felicitation ceremony. I request respected Principal Sir to felicitate Honorable Chief Guest, Dr. Sudhakar Pradeshi Sir. Thank you, sir.
Now, I would like to request our HOD sir to felicitate our principal sir, Dr. R.S. Sunzal.
Thank you, sir. We are really glad to announce that from our department, Dr. Amit Sonamne sir was recently awarded as Best Geographer Award 2021 from Maharashtra Bhugol Parishad. Congratulations, sir. So I would like to invite our Chief guest Dr. Pradeshi sir to felicitate Dr. Amit Sonani sir. Thank you, sir. I would like to invite HOD sir to speak few words on today's theme.
व्यासपीठावर उपस्थित असणारे महाविद्यालयाचे आदरणीय प्राचार्य डॉक्टर जिल्हाराव सर, भूगोल विभागाने जी 3 दिवसाची लेक्चर सिरीज ठेवलेली आहे त्याचे उद्घाटन पुणे विद्यापीठातील भूगोल विभागातील भूगोल विभाग प्रमुख डॉक्टर सुधाकर परदेशी सर या कार्यक्रमानिमित्त महाविद्यालयातील सर्व उपप्राचार्य, सर्व विभाग प्रमुख, माझे सर्व भूगोल विभागातील शिक्षक शिक्षकेतर कर्मचारी आणि माझ्या विद्यार्थी मित्रांनो, भूगोलशास्त्र म्हटले की बऱ्याच जणांच्या डोक्यामध्ये असं येतं म्हणजे जे अननोन असतात याविषयी, it is the only study of or analysis of rock, soil, natural vegetation and energy resource. But now that scenario has been changed, and all of you know that now with the digital age, the scope of geography has been expanded, such as GIS, Geographical Information System, remote sensing, RS, GNNS, all these studies, analysis has been analyzed with the help of digital age. So friends, total geographical analysis has been changed due to the changing age. So now, along with physiographical study, climatological, atmospheric study, each and every sector has been occupied by this geography. And next 3 days, the topics which we have selected with discussion with respected principal sir. First topic, application of remote sensing. Tomorrow, advanced surveying through drone. And tomorrow we have technical session in the library and then demonstration on ground. And third, at 7th, Monday 7th March, there is one interesting session, that is Kanchenjunga trek and its geographical perspective. म्हणजे तुमच्या लक्षात येईल की हे अत्यंत उत्तम असे विषय तुमच्यासाठी आहेत, त्याचा तुम्ही सर्वजण लाभ घेत आहात. मित्रांनो, हे सर्व लेक्चर सिरीज जे आपण आपल्या समोर निर्माण करीत आहोत, त्याचं सर्व श्रेय मी माझ्या डिपार्टमेंट मधील सर्व कलीग, टीचिंग, नॉन टीचिंग यांना देतो. आणि सगळ्यात महत्त्वाचं, आपल्या महाविद्यालयाचे सन्माननीय प्राचार्य साहेब, त्यांचं नाव आहे राजेंद्र. सॉरी सर, नाव फक्त उच्चारल्याबद्दल. Rajendra means king, and he is a king of total modern empire. And he is a lot of source of energy for us. not only teacher but also students. ज्या ज्या वेळेस असं वाटतं की विद्यार्थ्यांसाठी काय करावं, तर सरांचा पहिल्यांदा सहभाग असतो की हो आपल्याला हे करायचं. सर हा खर्च येणार आहे, सर होऊ दे, करायचे आहे. म्हणजे मित्रांनो, या राजाच्या एम्पायर मध्ये, साम्राज्यामध्ये आम्ही सगळे इतके सुखी आहोत. There are 36 departments in this college and 12,500 students are there in this campus. 36 विभागांचं नेतृत्व सर करतात. सर्व शांत आणि व्यवस्थितपणे परदेशी सर आम्हाला सांगायला आवडेल. आणि यांच्या साम्राज्यामध्ये आमचा एकूण एक घटक नॉन टीचिंग पासून शिक्षकांपासून इतके सुखी आहोत. म्हणजे या राजाच्या या साम्राज्यामध्ये रयत किती सुखी असावी हे तुम्हाला आमच्याकडे बघितलं तरी वाटेल. आणि माझं डिपार्टमेंट तुम्हाला काय सांगायचं, आम्ही 15 जण आहोत. सरांचं मार्गदर्शन आहे. एकूण एक आमचे शिक्षक जे आहेत, एक दिवस रजा काढली तरी त्यांना असं वाटतं आज डिपार्टमेंटला जायचं राहिलं. म्हणजे कधी डिपार्टमेंट मध्ये येईल आणि फुल ऑफ एनर्जी विथ न्यू सोर्सेस, न्यू टेक्निक, बरोबर. हे सगळे टेक्नॉलॉजी आहे. तुम्ही सोडून थोडासा. तर अशा पद्धतीने हे काम करत असताना मित्रांनो, अशा प्रकारची लेक्चर सिरीज आपल्या समोर आयोजित केली जात आहे. मी माझे विद्यार्थी, शिक्षक, आमचे प्राचार्य हे सगळे यांच्याविषयी बोललो. पण आता हे कार्यक्रम करत असताना तुम्हाला हे संपूर्ण जे वातावरण दिसतंय आणि आमची एनर्जी काय असते तर तुम्ही असता. 2 वर्ष आम्ही एनर्जी लेस झालो होतो, अगदी असं उभं राहायचं. आणि आता तुम्हाला बघितलं आम्ही अगदी असं होतो आनंदी. आनंदी का? हे चेहरे बघितले, ही एनर्जी बघितली की आम्ही पुन्हा एनर्जी होतो. याचं कारण माझ्या डिपार्टमेंट मधील महेश महाले, सिद्धी जाधव, साक्षी सिंग, चेतन इंगळे, अदा शर्मा, जानवी, नितीन, आयुष, ही सगळी टीम जी आहे गेली 3-4 दिवस, प्रियांका कुमारी मॅडम, सगळे आमचे सर यांच्या अंडर गायडन्स उत्तम तयारी करतात. म्हणजे मी तर पहिल्यांदा दरवाजामध्ये इतकं सुरेख 3 दिवसाचा कार्यक्रम लावलेला बघितला. मी या सगळ्यांना धन्यवाद देऊ इच्छितो. आणि तुम्ही केल्यामुळे या कार्यक्रमाला अत्यंत उत्तम आणि उच्च दर्जा प्राप्त झाला असं मला वाटतं. मित्रांनो, आजचे गेस्ट जे आहे डॉक्टर सुधाकर परदेशी. सिंपल लिव्हिंग अँड हाय थिंकिंग हे तुम्हाला या वयामध्ये, मला ते ज्युनियर आहे पण या वयामध्ये भारतभर आणि आंतरराष्ट्रीय पातळीवर दर्जाचा एक जॉग्राफर, एक सुंदर सायंटिस्ट आणि जॉग्राफी मधल्या न्यू हे आहेत स्ट्रीम्स आहेत, त्याच्यासाठी रात्रंदिवस हे शास्त्रज्ञ लोक कसे काम करतात, झटतात, याचं उत्तम उदाहरण म्हणजे आमचे परदेशी. आंतरराष्ट्रीय पातळीवरती त्यांची ख्याती आहेच, पण इस्रो सारख्या भारताच्या अंतराळ संशोधन संस्थेमधले रिसोर्स पर्सन असणं. आणि तुम्हाला गंमत सांगायची म्हणजे, टाळ्या वाजवल्या तरी चालतील, आपला भूगोल विभाग सुद्धा इस्रोशी डायरेक्ट ऑनलाईन कनेक्ट आहे. आपण ते संपूर्णपणे त्यांचे जे प्रोग्राम्स असतात त्याला आपण जॉईन होत असतो. याही गोष्टी मागचं श्रेय सन्माननीय प्राचार्य सरांना द्यायला मला आवडेल. मी काही खूप बोलणार नाही, मला इथं बोलायची संधी दिली. मी पुन्हा एकदा माझे सर्व सहकारी भूगोल विभागाचे, आपण सर्व विद्यार्थी, आमचे सगळे नॉन टीचिंग या सगळ्यांचे इथं अभिनंदन करतो आणि माझे 2 शब्द ऐकले त्याबद्दल धन्यवाद. थँक्यू.
Thank you, sir. Now, I would like to request our principal, sir, to guide us all on today's event.
I am really very happy to be here. we have organized a lecture series in geography. It's a 3-day event, as all of you know, and theme of the event is advanced techniques in geography. On the dais, we have Honorable Dr. Sudhakar Pardesi, Head Department of Geography of Savitribai Pune University. Our own Dr. Vilas Kamre, Head Department of Geography of our college. In online mode, there are some vice principals, heads of the departments, teachers who have joined this particular program. In offline mode, in this classroom, we have teachers of geography, teachers of some other departments, non-teaching staff members, student volunteers and participating students. I once again welcome you all in this particular program, which clearly reveals a lot of enthusiasm from the student volunteers, student participants, teachers, head of the department also. I wish to first of all congratulate the students who have taken initiative in organizing this program. When we give permission to organize some programs in the college, in our mind, the main aim, objective is giving our students an opportunity to organize certain things. Remember, in life, you might become some good employee in some company or government office or a businessman. Time to time, you will have to organize certain things. Might be the program, might be organizing for some activities, a process. So skill of organizing certain things or the events is very, very important. I am going to elaborate that point little later, but I wish to congratulate the student volunteers, students who have taken initiative in organizing the program. We teachers organize several programs many times, but we want that students should come forward. There was a slogan from our college only few years before. We thought that by the students, for the students. That was the slogan. I think we should take it forward. If it is by the teachers for the students, then there is a limitation. 12,200 students who have taken admission in our college, and there are 200 teachers. So ratio is not that attractive by the teachers for the students. So I think by the students, for the students, under the guidance of teacher, that will be very effective slogan. So students will come forward. They might give some suggestion that can we organize such and such program. And this is not exaggeration. In principal cabin, we receive several letters of invitation for conferences, seminar. So every year, at least 5 letters are the conferences organized by PG students of a postgraduate department in a particular university or in a particular college. So it is possible. Of course, we should go step by step. We should begin with such programs which are relatively easy to organize, a lecture or a lecture series. Then it can be some kind of workshop or some district level event, state level conference, national level conference, and it can be international conference also. So students coming forward to organize some events which are useful to the other students in the class in the college. So I think in that direction, students of geography have taken the right step. They have organized this particular event. I remember few days before the student volunteers, they came to principal cabin that sir, we are here to invite you. We have organized such and such program. Very nicely drafted invitation letter was there. So I was very happy. I could discuss with the students for not much, but say 3 to 5 minutes, and I encourage the students. So it's good that students have come forward. They are doing comparing very effectively. I am happy for that also. So I wish to congratulate the students for their efforts, and of course the teachers and head of the department for guiding our students in organizing this particular program. I know that teachers from animation are also involved. particularly in telecasting this particular program on our own YouTube channel. I think all of you know now, Modern College has a dedicated YouTube channel called Modern Media Station. Subscribe that channel. Presently, more than 7,000 students have subscribed. Through YouTube channel Modern Media Station, we have been interacting with the students and time to time giving guidance to the students. As you know now, college is keen about organizing international conference at least one every year, national conference at least one every year, state level conferences. So last more than 15 years, every year without single exception, international, national and state level conferences are being organized because we know that students appear to enjoy such events more than traditional classroom teaching learning process or traditional laboratory level teaching learning process. You people look more happy. There is more joy seen on your faces when you get opportunity to participate or attend this kind of programs. And therefore, as a policy, Modern College wants to continue organizing co-curricular and extracurricular activities. One example I would like to give, I was talking about skill of organizing. You know, every year, representatives of industry come to our college for so-called campus interviews for giving jobs to our students. It happens in computer science, statistics, and step by step, several departments. It is becoming a truth that campus interviews are conducted. So, as usual, after conducting the interviews, some students are selected, and of course, some are not selected. The student who was selected, next day he came with sweets to meet me in the principal cabin. So I asked him, what were the questions asked to you? You are selected, you are a student of computer science. How many questions were asked? He said 10 questions were asked. I asked him how many were there, how many of the questions were related with the subject. He said only two. Two questions were asked related with the computer science, and third question was related with what are your co-curricular activities. And he said, I participate in art circle. Art circle, you understand? Art circle activity. Fourth question, what exactly your role in art circle? Are you there in acting or singing or dancing? He said, no, I am not there in acting, singing or dancing. My role is to ensure that in shortest possible time, everything required on the stage is arranged, and in shortest possible time, the stage is dismantled. So you might think that what is there? He just arranging the stage and removing the stage. But remaining 8 questions, remaining 7 questions were related on this. What the industry expert might be thinking, in the whole life, the candidate will have to organize certain in given time. And his participation in Purushottam Karanda for organizing the stage and dismantling the stage gave him a job. Dear student, do you understand? This is a true, it is not a story, it is actual experience of one student. So why I want to tell you, do not underestimate participating in organizing small programs because you are learning certain life skills. Do remember this very actively. You can, whenever you get opportunity, do it. I always feel definition of obedient student in school and definition of obedient student in college varies. In school, a good student is one who listens to all the instruction of a teacher. But when you think about a college, only listening to the instruction of teachers is not enough. For becoming a good student, in addition to listening or obeying the instruction of teachers, I think you should come forward and give some suggestions of your for your own benefit. Very respectfully, you can talk to head of the department, teachers, that can we organize such and such thing? Ask a question. Maybe out of 10 such proposals, 8 will be accepted. But I think at college level, we expect you to come forward with some concrete suggestions of co-curricular, extracurricular activities for your own benefit. And I'm sure you will remember this. I will not take much of the time because we have to listen to the guest, but just 2-3 minutes more. You know that we have become autonomous college. So this is third year, and we have taken benefits of this academic autonomy. Last so many years before achieving autonomous status, we used to think about graduation attributes. What does it mean? A student of modern college should possess certain unique qualities before completion of his graduation or post graduation. That is referred as graduation attributes. We used to feel, it is our experience, most of the students in modern college are from villages and suburban part of Pune. They are actually hardworking, they are good students, but many of them are not confident about speaking in English. So when we got autonomy, we designed English communication course. E-contents are developed. It is online, and we are ensuring that every student, complete that English communication course. We have not stopped there. We feel that every student of modern college should get some knowledge of law, which governs him in future as an employee or as a businessman. Some legal awareness. So that due to autonomy, we have a legal awareness course designed. E-contents are designed. We are offering that legal awareness course also. Then it was my idea that our students should have some kind of managerial skills. They should know some skills of management so that they will become good employee or good businessman. So managerial skill course is designed, e-contents are developed, and the course is being offered to the student. We talk about value education, Jivan Mulya, very, very important. So we have designed a course with e-contents, value education course. Every student in modern college will complete that. Then music is important part now in National Education Policy 2020 has been launched by Government of India, and in that music and cultural aspects are given importance. So we have decided, in fact it is done already. The Department of Music of Modern College has been established. Next academic year we will start with BA Music and some short-term courses also. So a lot of things, due to autonomous status, we have designed certain things which are useful to the student. As far as science student interested in scientific things, we have an advanced equipment and laboratory established in chemistry department, like gas chromatography, HPLC and all that. If some of you might be interested in that, just go and meet the Dr. Sakte from chemistry department, show your interest in that, and go through the facilities over there that I wanted to tell you. Then one more thing, do you know that we launched Yuva Sansadan scheme project? Yuva Sansadan scheme is very important to students interested in research. It is like if a teacher like us needs some funds from government, we prepare a proposal, research project. We submit it to the funding agency at Delhi, and then they call us for giving presentation. It can be called as defending the project, that why I need money, and then they sanction it. We feel that students of modern college should get experience of similar things, maybe at miniature level. So we have kept 1 lakh rupees of funding through college budget. Every group of students will get 5,000 rupees for completing a small research project. That is called Yuva Sansadak scheme, as the name indicates, young researcher. If you are interested in doing some small kind of research project under the guidance of teacher, for which you will get 5,000 rupees, you should meet head of department of microbiology, Dr. Shilpa Muzumdar, and show your interest that you are interested in such and such things. That I wanted to tell you. As it was already mentioned, we have 11 recognized research centers in our college, recognized by Savitribai Phule Pune University. 4 more are going to be established in this academic year: mathematics, chemistry, computer science, and geography. So there will be 15 research centers in modern college, 23 PG programs. MHO Fashion Technology is going to be started from June. So there will be 24 plus MSc Animation, 25. Experts refer our college as mini university. 25 PG programs, 15 research centers, 12,200 students, highest number. In many big colleges in Pune, And even in Maharashtra, number of students has decreased in COVID period. Modern college is exception. Number of students increased by 1,500. Credit goes to all my colleagues and our policy of serving the student community. Like our Prime Minister says, I am Pradhan Sevak of the country. I have taken inspiration from Honorable Prime Minister. I am Pradhan Sevak in modern college. So even though out of affection, Dr. Kamble mentioned about empire and Rajendra and king, it's good to listen. But आमचा हा सेवाभाव फार मोठा आहे. Service, not only service, service with a smile. You will find everybody in modern college smiles, including principal, whole day. 12,200 students, but when you help somebody, the happiness hormone in our body gets secreted, serotonin, scientific. When you help somebody, happiness hormone called serotonin gets secreted in the body and you feel happy. You should help yourself also. Who will help you otherwise? Help yourself, help everybody. Serotonin secretion, happy. We have another concept. We want modern college to be anger-free zone. Do you agree? Anger-free zone. No need of anger. People tell me then how you will run the college. I said this is 14th year as a principal. 32 awards are there to the credit of a college in 14 years. And I think nothing wrong has happened by not becoming angry and only helping people and help with a स्माइल. तर आपला तो मंत्र असेल मित्रांनो, मॉडर्न कॉलेजचा काय मंत्र असेल? सर्व्हिस विथ अ स्माइल अँड एन्जॉयिंग स्टडींग ऑल्सो. सो दॅट I will have to stop here. There were few points, but just one I will share and then stop. It's very useful to you. Many of you have been completing a small research project and preparing a report and submitting to the department because it is a part of curriculum and marks are there, isn't it? Doing a research project, research work, writing project report, submitting, evaluation and marks. Now just one step ahead, very sincere appeal, one step ahead. If you can prepare a project report of 50 pages, 80 pages, 100 pages, you can easily prepare one page research journal. Strictly one page, that will be your skill. Research paper. Just go to library, refer to some research journals, you will find some research papers and look at the contents of research paper. There will be a title of a research paper. All of you know title of a research paper. Then name of author or names of author, address of author, then maybe some summary, abstract or something, introduction, material methods, results and conclusion, and references. But one page is the rule. One page miniature of research paper. So what we will do, we will compile all those one page type of research paper and collectively one in-house research journal will be published by our college. In fact, we have done it already in the form of a CD or in the form of a print copy. You can easily mention that my research paper entitled that has been published in the in-house journal of modern college entitled that volume number, year, page. I think it will be great achievement. So our students, if they can write a research project of 100 pages, they can easily write a research paper of one page. Isn't it? Try this year. We will like to see that it comes into reality. It is not imaginary. Regular one national level conference organized at Calcutta. Head of the Department of Biotechnology, she attended it. After coming back, she showed that proceeding to me, and it was a unique feature. Every research paper was one page. So the idea is our students learn how to write research paper on miniature scale. I think this year or at least next year, we will see that it comes into reality in our research journal of modern world. At the end, I wish to mention certain unique features which I have noticed from geography department. They have been organizing Geo Fest every year. Because of COVID situation, they could not do it this year. But next year, I am sure Fest 22-23 will be there. We have a sewage treatment plant where 20,000 liter water can be recycled every day. Geography department has taken initiative, and that is good thing about the department. Several environmental audits, green audit and biodiversity and all that is expected from a college. Geography department is coming forward, and ISRO Dehradun collaborated online course. That is another feature. Facility wise, every department in modern college is very rich, because when we sit for purchase committee, as you know now, service with a smile. So we sit there just to say yes to whatever head of the department proposes. Still nothing wrong has happened. Isn't it, sir? We agree. We sit there to say yes. And that the reason is, the result is very rich departments, all kinds of facilities, because they are useful for the student. How can we say no? So that way, facility wise also, our department is very good. At the end, dear student, I would like to mention, try hour of truth. Satyachi Shakti. When I became principal, before that I was not vice principal of a college. Only experience of 6 months as the head of the department of college, and then a principal of big college. So I thought that power of truth should be used. सत्याची शक्ती. समजते तुम्हाला? सो सत्याने जाणार असाल तर ती शक्ती तुम्हाला फार मोठी मिळेल. त्या दृष्टीने वाटचाल करा. दुसऱ्याला मदत करण्याचं सांगितलं काय. देर आर 55 ब्लाइंड स्टुडंट. इफ यू सी देम गोइंग टुवर्ड्स the main gate, ask that girl or a boy, do you want to cross the road? Help him. You will be very happy. So basically, as Kamble sir has said, to be in the college for more than 1 year, 11 months without student was a big challenge to us. Because for we all teachers, main source of energy is presence of the students on the campus. So फार मोठी पनिशमेंट आम्ही भोगलेली आहे without students coming to college every day. But we all are very very happy to see you here in the college. आमची अशी भावना आहे की मोठी मोठी स्वप्न घेऊन येत असतात. ही सगळी स्वप्न आहेत आणि आमचं काम आहे त्या स्वप्नांना काय द्यायचंय, काय जोडायचंय, पंख जोडायचे. आमची पंख लावण्याची दुकानं आहेत, पंख लावण्याची ठिकाणं आहेत. तुमचे स्वप्न जे आहेत त्यांना भरारी घ्यायला आम्ही नक्की मदत करू. सर्वांचं मनपूर्वक अभिनंदन. जरा जास्त वेळ घेतला. पाहुण्यांचं पुनश्च एकदा स्वागत. थँक्यू.
Thank you, Principal Sir. Further, let's understand our today's theme. So I would like to hand over to my co-anchor for this information.
Thank you, Janvi. It has become a regular aspect and part of our college to conduct academical programs and to organize various symposiums like this to better enhance and get acquainted with the knowledge and experiences of expert teachers and professors from all over Pune. So, today, to better understand and grasp topics like GIS, geoinformatics, and sensing data acquisition by satellite, our respected chief guest, Dr. Sudhakar Pardesi sir, is going to address us all on the topic of application of remote sensing and its importance. In this modern world of satellites and sensor technology, it is necessary for us to understand how remote sensing and geodesy play a vital role in acquisition and determination of various weather and climate patterns, environmental monitoring, meteorological variables, tectonic shifts, and oceanic activity. So, we welcome you all on this journey to better understand our planet Earth and its relationship with us.
Thank you, Naveen, for giving this piece of information. So let's be enthusiastic for this topic. Now, I would like to hand over to Siddhi and Mahesh for giving us information about our today's chief guest, Dr. Sudhakar Pardesi sir.
धन्यवाद जानवी आणि नवीन. आतापर्यंतच्या आपल्या कार्यक्रमात आपण प्रिन्सिपल सरांचं मार्गदर्शन पाहिलं. नमस्कार, मी महेश.
नमस्कार, मी सिद्धी. तुम्हा सर्वांचे पुन्हा एकदा स्वागत करतो.
आता आपण आपल्या कार्यक्रमाच्या पुढच्या सत्राकडे वळूया. पुढचा सत्र हा खूपच खास असणार आहे, कारण आजच्या या आपल्या कार्यक्रमाला लाभलेले आपले प्रमुख पाहुणे डॉक्टर सुधाकर परदेशी सर यांची आपण ओळख करून घेणार आहे.
Hence academic qualification, MSc in Geography, MTech in Remote Sensing and Geographic Information System and PhD in Geography. Designation, Professor Head of Department of Geography, Savitribai Phule University, Pune.
Research interest, water resources, environmental, coastal and applied geomorphology. Applications of remote sensing and GIS in geography. Research project, morphometric assessment of anthropogenic landforms for land resource management in suburban areas of Pune city, Maharashtra. आणि एवढेच नाही तर सरांचे बऱ्याच संशोधन आणि शैक्षणिक संस्थेमध्ये सदस्यत्व सुद्धा आहे, जसे की इंडियन सोसायटी ऑफ रिमोट सेन्सिंग, इंडियन मेट्रोलॉजिकल सोसायटी, इन्स्टिट्यूट ऑफ इंडियन जिओग्राफर्स पुणे आणि एवढंच नाही बरं का, इन्स्टिट्यूट ऑफ जिओमॉर्फोलॉजिस्ट ऑफ इंडिया अलाहाबाद आणि असोसिएशन ऑफ अमेरिकन जिओग्राफर्स.
अजून सांगायचे झाल्यास 5 इंटरनॅशनल रिसर्च पेपर्स, 4 रेफरन्स बुक्स असोसिएटेड विथ वॉटर मॅनेजमेंट, जिओमॉर्फोलॉजी अँड रिमोट सेन्सिंग आणि तसेच बऱ्याच राष्ट्रीय आणि आंतरराष्ट्रीय परिषदांमध्ये त्यांनी सहभाग घेऊन रिसोर्स पर्सन म्हणून काम केलेलं आहे.
आणि जॉग्रफी प्रती असलेल्या रुचीमुळे त्यांनी वेगवेगळ्या 12 देशांमध्ये भेट दिलेली आहे आणि संशोधन पर्सन म्हणून काम सुद्धा केलेलं आहे. अशा सर्व क्षेत्रात सक्रिय असणारे आणि संशोधन वृत्ती जोपासणारे आजच्या आपल्या कार्यक्रमाला लाभलेले आपले आदरणीय प्रमुख पाहुणे डॉक्टर सुधाकर परदेशी सर यांनी वेळेचा विलंब न घेता आपल्याला व्याख्यान देऊन उपकृत करावे अशी मी त्यांना नम्र विनंती करतो. तसेच सरांचं व्याख्यान झाल्यानंतर आपण एक क्वेश्चन आन्सर सेशन सुद्धा आयोजित केला आहे. जर तुम्हाला काही प्रश्न असतील तर तुम्ही नक्कीच विचारू शकता. धन्यवाद.
Still, it is good. Good morning. Good morning, all of you. I'm very much thankful to Professor Principal Gunzadar sir and Dr. Vilas Kamble sir for inviting me as a chief guest and resource person for this particular lecture. It is indeed a pleasure to come here after a long time. I used to come here to teach surveying when Dr. Aida was in charge as a head of the department. It was in late 90s and early 2000. At least 2-3 years I was here for one semester. And after that, after a long time, I'm visiting this campus once again. And it is indeed a change, a good change I have seen. Thank you very much, sir, for inviting me and giving me this chance to interact with the students. When I asked Dr. Kamble about the audience, he said that there are students from different backgrounds. So I thought to start with the basics of remote sensing, because some of you are not aware, and many of you have already studied these basics. If you have done certain basic courses of IIRS or any other remote sensing GIS course, this would be very basic for you. But keeping in mind about the audience of different, the students of different departments and disciplines, I thought I would start with basics of remote sensing to understand how remote sensing process is done, and then I will shift to remote sensing applications. So friends, it is a very well-known technique nowadays. It is not really new. In late 70s, India has started all these kind of programs, that is through ISRO, that is and Space Application Center. And after that, there is a good development within 30-40 years in the application of remote sensing data and the remote sensing technique. With this, I would like to go for the next slide. First, try to understand what is remote sensing. whatever we do, that is done through remote sensing. For example, I'm looking at you and you are looking at the board. That is also remote sensing. And very recently, all of you have taken the experience of remote sensing too, without seeing the person or without touching the person. Right? All of you have gone through the test or the temperature detector. What is this called? Because of COVID, you have been always asked to raise your hand, and the person who used to test your temperature, right? Thermal detectors, without touching your body, it was detected that you have normal temperature or high temperature. That is also remote sensing. So anything, any information we acquire without being to that place, everyone is comfortable with English, right? तुम्हाला जर काही वाटलं तर तुम्ही विचारू शकता. At any point of time you can stop me and ask. There is no limit. So without being in touch with any object, you can sense or you can collect the information about that object. That is nothing but remote sensing. It is not only collection of the data, it is collection of the information which is useful for the different applications. Earlier, remote sensing was done just to do Earth observation. Like what are the resources, how the resources are distributed, and how we can map those resources. That was the aim earlier. But slowly we could found that there are many indirect outcomes of this remote sensing process. So these indirect outcomes are two different sensors, like thermal sensor or microwave radar sensor, which are giving us indirect information. For example, I'll give you one simple example: clean water, clean clear water, and polluted water. The thermal properties of these two types of waters are different, which we cannot see through the eyes. But if you use thermal sensor, definitely the polluted water will have different signature, different amount of emission and reflection. So thermal infrared is used in both the type. One is reflected and second one is emitted range. We'll see that kind of remote sensing later. But such kind of things are possible because of remote sensing, which we cannot see through our eyes. That is the advantage of remote sensing. Whatever we could see, that is only through the visible portion of electromagnetic spectrum. You might have heard this. Electromagnetic spectrum we have studied maybe school days or maybe first few years of your college, right? This is what is electromagnetic spectrum. The light is divided or separated on the basis of frequency and wavelengths. So this is the spectrum, very narrow part of the light which we receive on the Earth surface, through which we can see the entire world. Remember, this is very narrow part. The rest of the part of the light or solar energy, incoming solar energy, that is not visible to us. Okay, no problem. No problem. So on the left hand side, what you can see gamma X and ultraviolet radiation. Some of you are already aware of this. On the right hand side, we have longer wavelength radiation. Longer wavelength radiation means the waves are wavelength is more than the visible range. And what we could see 7 colors. Normally we see 7 colors, right? Yes or no? 7 colors. These are the partitions or divisions of main 3 colors. Main 3 colors in this solar energy or spectrum is blue, green, and red. So these are further divided in 7 different colors. Okay? So these are visible colors to us. So I could see different colors. You can see different colors. Okay, like red, black, white. This is because of the reflection of the light from that surface. Same technique is used in remote sensing satellites. Solar light or solar energy is used to illuminate the surface. The light is reflected back and it is recorded, just like your camera. Now, what do we do in camera? We use camera in daylight without flash. Yes or no? When the light is less or the intensity of light is low, then what do we do? The flash is turned off. Sometimes it is automatic. Sometimes you have to turn it off. Right? So that is again a kind of different remote sensing. We discussed that part. Let's go on. Yes. How can you see the image? Any image. We can see the image just because of the reflection of the light from that surface. Now the person is wearing yellow, the girl is wearing red, the boy is wearing black, right? All these things are because of the reflection. Now if particular light is reflected from the surface, that means what? The rest of the part of the light is absorbed, right? The intensity of light is also very important. Within same color, you have different shades. For example, there are many red shirts and t-shirts, right? But all these red t-shirts are of different intensity. Meaning what? Within red, you have different shades. Human eye can detect, or the brain can detect very few shades of color, any color. That may be around 12, 13, particularly girls or ladies, they are having more capability of detecting the shades because of experience. There is no special capability in the eye, because of the experience, right? So that is the limited capability. But computer has the ability to detect hundreds or thousands of shades within one color. That is the one important aspect that is used in remote sensing. For example, here you are getting two green colors in two photographs. On the left hand side, it is the Department of Geography. On the right hand side, it is main building of Pune. So there is a lawn that is also green, and the plants in front of the department that is also green. What is the difference here? Color shade and intensity of light. So remote sensing has an ability to detect very minute change in colors, provided the insolation and or you can say angle of incidence. You have studied this angle of incidence and angle of exitance. Okay, that is maintained. So the orbital path of the satellites are always designed in such a way that the angle of incidence and exitance at particular path is maintained. Both these angles are maintained. And every time the sensor will get the same amount of intensity of light naturally. If there is some problem, then the intensity of light will change. For example, this is white color, okay? Tablecloth is white. If I put black, then it will be detected. There is no change in the light that is falling on the surface. What has changed? The surface has changed. There is vegetation green. If I remove that lawn, it will become brown. Light intensity doesn't change. Incident energy and the energy recorded by a sensor, that has not changed. What has changed? The surface has changed. So in this way, change detection through satellite images are done. So if the surface is varying, definitely there is change in the surface, not in the energy. In the energy also, the changes that are taking place maybe because of cloud cover, maybe because of hazy condition, atmospheric conditions are different. In that case, insolation changes. Maybe the sensor is not working properly. Once you have sent the satellite into space, you cannot go and repair the sensor. No. Sensors are not working properly. Malfunctioning of the sensors. So in such cases, the satellite images are problematic. Okay. Next, please. This is simple mechanism. That's what I told you. Through human eyes, we can see different colors. On signal, you can see red, orange, and green. Right? That is because of we have the capacity to detect the color. your mechanism of your eye has that capacity to detect the color and send the signal to the brain. Same thing is done in remote sensing. That's why this is what I told you. Solar energy that falls on the surface. From the surface, it is reflected and it is recorded by the sensor, just like your camera. Okay. Some of the energy is absorbed in the atmosphere. That's why we get the very little energy on that surface. Remember that we get very less energy on that surface. Out of the total energy sent or received. Then incident radiation that falls on the earth surface. Then reflected radiation. The term is used radiation. Some energy scattered in the atmosphere, scattering from the atmosphere and clouds. Okay? That's why the sky is blue. Sky is blue because the blue light is scattered. Blue light is scattered because the wavelength of blue portion, blue light is less. The wavelength is small, right? Or you can say short. That's why blue light is scattered. Blue light can penetrate in the water because of the shorter wavelength. That's why most of the water bodies are seen blue from the long distance. That is the mechanism. So such kind of radiations are used to record in the sensor. Next one, please. Now we have different surfaces. This is the remote sensing process. Quickly, I'll explain this. Solar energy that is falling on the features on that surface. It could be building, it could be lawn, it could be tree, anything. From there, it is reflected back to the satellite. From satellite, it is recorded in the satellite. It is sent to the ground station. That is called data collection center. Okay? Or ground station. Like I have put antenna for representation. So from there, it is sent to the experts. There they do the processing, and from there the image is sent to the user, like us. So this is the procedure. And every time, earlier it was a problem that every time the satellite should be in front of the receiving station. Now we have different receiving stations throughout the world. So at any point of time, we can collect the data and we can get the data from those stations. The end user, like us, they are using the image that is shown. Again, represented image. Next one, please. Yes, this is very important to understand how satellites work. You can see here, same thing again. Solar energy is falling on the Earth's surface. Some of the energy is blocked by the cloud, which is reflected, and again, the same can be recorded by the sensor. Because there is always mixing of rays, scattered light in the sky, and from there, it is recorded by the sensor. So there is no separation at the sensor. Whatever the energy is received from the particular area, that is recorded. Now there are two types of movements of the satellite. One that is moving from north pole to south pole direction, vertical. Suppose this is Earth. So from the cap, it goes towards the bottom. So this is polar orbiting Earth observation satellite. The second one is around the Earth. It moves along with the Earth. Like this is the Earth rotating. Okay. And now the satellite is facing this grid level. For example, this is India, and the satellite is facing India. So it should always face India, day and night, 24 hours, all the lifetime of the satellite. So it will move something like this, along with the rotation of the Earth. So these are called geostationary satellites. The previous one, polar orbiting sun synchronous satellites. Most of the sun synchronous satellites are using the energy of sun. That's why these are called sun synchronous satellites. These are called passive sensors, passive. And the other sensors which are using their own energy are active. Go to the previous one. Previous. Yes. Now we can see solar energy is recorded by the satellite. And you can also see there is one arrow that is coming from the satellite and going back to the satellite. Right? This one. Maybe the arrow. Yes, the satellite sends the energy towards the object, and then the same energy is scattered back and recorded back by the satellite or sensor. This is called active remote sense. This is done when there is no sufficient light, number one. Maybe night time it is required. Number two, if it is cloud cover, like the energy, solar energy is blocked in rainy season particularly. Solar energy or light is blocked by the clouds, so the light cannot reach to the ground and no reflection takes place, or the amount of reflection is less. So in that case, the energy received at the sensor is less. So in such cases, we can use active sensors, active remote sensing. So the active remote sensing, the important example is microwave remote sensing. So microwave has the ability to penetrate through the clouds. It can pass through the clouds, reach to the earth's surface, and come back to the sensor. So that is called active remote sensing. Right? Have you understood this? Any questions so far? I hope you have understood. This is basic part. Now I'll come to the information related to application. Before that, I would say I will show you some of the diagrams. Of course, these are available on internet. You can check this kind of details. Electro-optical imager or images or imagery. Electro means these are the electronic devices. Optical related to lenses, light. Okay. So these electro-optical sensors are placed on the satellite. Satellites are moving around the Earth. About 90 minutes it takes to complete one orbit at the altitude of 700, 800 kilometers above the Earth. Recent one, you might have seen 200, 300 low orbit satellites are there. High orbit satellites are also there, about 800 kilometers. Geostationary satellites are about 3,000 to 33,000 kilometers away from the Earth, so that they can cover most of the path here, like meteorological satellites. Okay, these are very far and constantly looking at the Earth at the same position. So these are some of the images to which you can get an idea about the application, like water, vegetation, then concrete surface, and other objects that reflect light differently. Now, these are different objects on that surface. Most of these are natural objects. You can see the whirling or cyclone feature, right? Towards the right hand side. Then the middle one shows glaciers and the vegetation. The extreme left is coastal areas. So all the features can be seen through the satellites. And all of you use Google Earth. Have you seen images on Google Earth? How many of you have not seen? You don't know what is Google Earth. Not Google, Google Earth. Please raise your hand. It is quite possible that you have not seen Google Earth. So I would suggest you to go through Google Earth. In Google Map also you have two options. One is map, other one is satellite. Try to find out your own location. Try to identify the features around your college, around your house, right? So that is interesting. This is how you can use satellite images just to understand the surrounding area, just to understand the Earth's surface. And after that, analysis comes. This will be your visual interpretation. If you are having certain softwares, you can do the other kind of analysis. You can find out the area, you can find out the differences in the features. Such kind of analysis is done. Next one, please. So these are again images. Some of the images are literal images, some of these are non-literal. So the images which are shown are using light, span, color, and some multispectral. The second one, non-literal, means radar, thermal infrared,
sonar, hyperspectral, and other images. That means you can use camera with infrared. Camera with infrared. You will get CIR, you will get TIR, thermal infrared. So these are the images which you will see. Number one is panchromatic. There is difference between black and white and panchromatic. Anybody knows about this? Black and white and panchromatic. There is difference. What is that difference? You can see panchromatic image. Is it black and white? Yes or no? Is it black and white? No, it is not. It is not. I'll tell you how. This is black, right? The lettering is black, right? The background is white. It is high contrast. Either black or white. Check the image. Is it either black and white? There are hundreds of shades in this green. That's why it is called panchromatic. Gray shades are there. Similarly, if you look at each color band, it may be red, green, or blue. If you take a single band, it will be panchromatic. It will be seen panchromatic. If you combine the bands, then it will be color band. So middle one is color one, and the last one is multispectral. Multispectral is again color one with different combinations. That is called standard FCC. Then you will see the vegetation green. That is standard FCC. So such kind of combinations are also used to identify or to get indirect information from the satellite image. Not only color, regular color combination will get. That is true color. Besides that, we can use different combinations, false color composite, which will give you different colors to different objects. Like vegetation should look green, but in FCC it looks red. Okay, that is false color composite. So you'll get better information if we are using different FCC. There are again different variations. IHS you might have heard. Intensity, hue, and saturation. In case of photography, you might have heard this. That you can change to get different details of the features. Next one, please. Again, you can use remote sensing, spatial resolution. Definitely, that is again interesting part, but it will take lots of time to explain all this. Spatial resolution is the ability of the sensor to detect particular object, size of that particular. What is this picture? Can you imagine? Because the spatial resolution is poor, it is not possible to do. Definitely, there is a picture, red color picture. Any guess? No? Obviously, these are the pixels. This single box is called pixel, right? And the pixel has the area determined on the ground. So the sensor, just like your LED light, the sensor looks at that particular area, not beyond that. If this area is determined 30 by 30 meters, that is called resolution, spatial resolution. Any object larger than 30 meters will be detected by that sensor. Anything smaller than that will not. For example, this is the desk, podium. This bottle is very small, the mic is very small, and pixel size is this one. So I'll get the reflection of the light from this podium, this area. It will cover the mic, it will cover the bottle. Reflection from the bottle and light mic will not be seen because this is a large area and you will get the average reflection from one pixel. So you'll see only podium top, right? Not the mic and bottom because the sensor has not the ability to detect such small feature. Next one, please. Now you can guess. What is that? A car. You can see, right? Next one. Definitely it is a car. How it is possible? Because the pixel size has reduced. Pixel size is same, but the ground coverage is reduced. right? Like we have different cameras, megapixel and all, right? How the camera quality increases, number of pixels are more. Then only camera quality, the picture quality increases. Same technique is here. If the pixel is small, you will get the details. If the pixel area coverage is large, you will lose the details. Next one, please. This is very important aspect in satellite. So you can see there are different satellite sensors like Landsat 8, then Worldview 2, and then the last one is airborne source. It could be photograph or airborne image. You can see the area coverage on the ground 30 meters, then 0.63 meter, and the last one is 0.1 meter. That is sensor, right? So we have Cartosat 3 by ISRO. Recently it was launched, and it has the ability of detecting any size, any object of say 25 centimeters size. 25 centimeters. Your scale. 1 foot scale is 30 centimeters. Right? So if I put the bottle on the ground, it will be detected. It will be detected. Next one. Spectral signatures of material. This is also an important aspect. I will explain it later. Yes, this is the spectral reflectors. As I told you, I could see you because of the reflection. Now, each person is wearing different shirt or t-shirt. I could identify the colors because of the reflections. Now, each surface has its own signature color or signature reflectors. Like every person is having unique signature. Similarly, the objects on the Earth surface are having unique reflectors. And this is compared with the signature library. Signature library, that means the reflected light is recorded by the sensor, handheld sensor. Then it is compared with the satellite data. And then on the basis of that, unique reflectances are identified. These are called spectral signatures, spectra of that particular object. Like vegetation. Within vegetation, also you have different types of trees. Like maple, then what you can say, lodgepole, right? So these are the different reflections. Light from the water, that is blue, sea water, along the coast. So that reflection is very less. On the left hand side, it is reflectance, and on the bottom, it is wavelength. Okay. So these are the signatures through which particular objects are identified through satellite images. Next. Image is also having different bands. Bands means the physical portion is broken. Like I told you, blue, green, red, infrared. These are the bands which are used in one single image. If you look at one single band, it will be panchromatic. If you combine two bands, it will be colored. Or three bands, it will be colored. So we should have the color combination of RGB. RGB to display. And BGR from spectrum. BGR, blue, green, red. Blue scatters more light. Blue scattered. That's why sometimes blue is replaced by infrared. In Indian remote sensing satellites, blue is replaced by infrared. Okay, so you have minimum three bands required, but then infrared you can see through the blue channel of the display system. This is display system, like projector is display system. Your computer screen, TV are the display systems. You can put any band there and it will be displayed. Right? So that is different part. We'll discuss that some other times. Next. Images of bands. On the left hand side is single band. On the right hand side is combination of three bands. So you get the better picture on the right hand side. Right? If there are multiple bands, you will get the better understanding of it. You can see the resolution cover, you can see the desert, the famous desert of Africa, Sahara, right? And how the resolution changes? It is not direct change. There is no equatorial forest and then directly Sahara desert. No, in between there is gradual change in the resolution that we can identify through satellite images. And for entire Africa, for entire world, we can use the satellite data, process it, and we can generate the scenario of the vegetation distribution in the entire world. That is possible only because of satellite images. Otherwise, manually it is not possible. Next one, please. Yes, these are some of the satellite images used in GIS applications. For example, if I have to check the sea surface temperature, so thermal detectors are there, surface temperature, land surface temperature, and sea surface temperature throughout the world can be done through satellite images. Every year you can do this kind of exercise. So, for example, what was the temperature in 2020, 2021, 2022? In the month of March. Every year you can do this exercise for the entire world. Manually it is not possible. Now, advent of processing through computers and resolution of satellite data. That is very important. Spectral and spatial resolution to prepare such kind of analysis. But there are applications in mining, then natural disaster, then development. You can check the development of any urban area. Many scholars in geography, they are working on urban fields, urban development. They use satellite images of different phases. Like suppose you have to check Pune city development. So what was the condition in 1980, 1990, 2000, 2010, 2020, and on the basis of that, they can find out the trend. What will be there in 2030, 2040, such kind of applications can be done. Now we can change detection in land cover. The earlier picture and the next picture. This is what I told you. You can find out change detection. Why? How could you find the change? The basic principle is the light that is falling on the surface is same. Today you are here. After 8 days you will come in the same classroom. The light is same. Right? At the same time. You open the door, open the window, you will find the same light. If I place the paper on first day, it will be different object. If I remove the paper, different reflection. On this principle, the change detection is because the light intensity remains same. Next one, please. This is already discussed, but yes, I have purposely kept this part. This left part is of no use in remote sensing. Left of visible. Right part is used in remote sensing in the radio waves. So, visible portion is used in passive remote sensing and non-visible, which is in black and white part. Right side, that is in active remote sensing. That's a thermal infrared and some portion of microwave remote sensing. That is done both in passive and active. Thermal is done in both passive and active because of releasing of the heat from the surface. Now, application of remote sensing to understand climate change indicator. This is one example I will take you. Before that, I will tell you very small applications, and then finally I will go for this. Let's see. Climate change. There are different indicators. Number one is vegetation, or it may be seasonal variation also. For a short term, you can use this kind of technique. Vegetation, when it is having healthy growth, any plant it will be outside. If it is having healthy growth, it will be green, very well grown, flourished, right? If it is having shortage of water or any nutrients, or maybe very high temperatures outside, so it will start wilting, drying, and then the reflection will be same plant. If it is healthy, reflection is different, and same plant if it is non-healthy, reflection will be different. So, on this basis, the plant health, vegetation cover, forest cover, crop cover, all these things can be identified. If the crop is having certain kind of disease and the crop cover that is disturbed, I mean the green color, the health of the crop is disturbed, then that can be detected through remote sensing. It is possible. That kind of technique is available. And crop estimation is also done on the basis of remote sensing nowadays. Net zone area. Have you heard these terms? Net zone area. area under particular crop. Now, all the crops are having different spectral signature, specific reflectors. For example, sugarcane. For example, wheat. For example, rice or paddy. So these signatures are compared with the satellite data, and the area under paddy, sugarcane, wheat is estimated for the entire country. And then they estimate with the help of average yield per acre or per hectare. They estimate the total estimate the total crop production for the year. Based on that, different prices are decided. So it is not only just to identify the crops, but for the crop production estimation also, and market prices are decided on the basis. Right? Next one. This is what is done through NDVI. This is one index, a ratio of the bands that is used to find out greenness on the earth surface. This is one example I have taken from the internet. This is not my one. So NDVI is used to identify the cropland. Second one is forest cover. The top two maps are showing cropland and forest cover. The bottom two are showing only forest cover. So you see the changes, right? 2000 and the other one is 1982 to 2000. Next one is 2000 to 2050. Within this time, how much change has been taking place in the forest cover? Next one, please. Use of thermal infrared (TIR). TIR is not visible to human eye, but we can sense increase in temperature outside. Our skin has that ability. We can sense the increase in temperature. We can sense increase in light intensity because of the hotness. So TIR is used to identify different weather phenomena, weather conditions, right? Like you can see the cloud cover, you can see the water vapors, which we cannot see. Water vapors cannot be seen, which are there in the atmosphere. So, but through meteorological satellites, we can see such kind of details of the weather conditions. So, this is taken yesterday only. You can see the day and the time. Okay. Next slide. This is from IMD. It is very interesting. You just go to the IMD website and you check all these details of the satellite images. You'll find very interesting part. Every day you can keep on checking these images. You'll get the updates, daily updates. This is for the entire globe. So geostationary satellites are used for such kind of observation. So if the half of the Earth is covered by using 3 or 4 tiles or maximum 8 tiles, 8 images, and you'll get the overall scenario, synoptic view of the Indian Ocean, right? You can see India and the southern part is Indian Ocean. So all these regions were Aniket is there, he is having climatology as a specialization. I'm so sorry. It's not mine. So this happens with the So this kind of scenario can be identified. You can study if you are interested in study of meteorological parameters, or if you are doing climatology, it is very interesting to use such images. This is radar image. Radar, as I told you, thermal infrared is not visible. Radar or microwave remote sensing is again very complicated part, and from this image you will not get anything. At least in visible or thermal infrared we can get something, but radar image is very complicated. We have to do lots of modeling. Nowadays, fortunately, many of the softwares are having inbuilt applications of microwave radar analysis. Okay, so this is NVSAT radar image. It is showing land subsidence. Of course, you have to be very observant to check what kind of land subsidence. Radar has the capability to detect the subsidence. Subsidence is what? Land is going down, subsiding. Now, radar has the capability to check such kind of changes, few millimeters. If I remove the cap, it will detect. If I put the cap, it will detect. So few millimeters of vertical variation can be identified through radar remote sensing. That is the photography. Many of these scientists from IIRS, they have studied subsidence in the Kolkata city, land subsidence. And you might have heard about the mining. Coal mining causes subsidence of the surface. If you remove the coal from the lower part, the surface subsides down. So that kind of surface detection is done through radar remote sensing. That is one important application. Next one, please. Application of RS in glacier. This is my study, I would say. The climate change. Next one. Remote sensing allows us to map many features, and glaciers are one of these features, which there you cannot go physically because these are inaccessible areas. Remote sensing helps you to go to that particular area. I mean, you can study that area without being there. Suppose I would like to study Antarctica. Today I can do it. I can study of Antarctica without being there because I am having different satellite images of Antarctica region. I can go in Himalayan areas for the study, but our entire area is not accessible. I cannot reach there. So in such cases, remote sensing helps us to find out what are there. Next one, please. Very quickly, retreat of snout is very important. Change in snow cover, area of snow accumulation, then formation of supraglacial lakes. I'll explain very quickly all these things. Supraglacial lakes and water bodies and change in movement of change in movement rate. Glaciers move, right? So there is always differential movement. The rates are different. In 1 year, it is very, very fast, and the next year it will be slow. So that kind of change can be identified. Okay, glaciers are one of the many climate change indicators, and in IPCC reports, glaciers were given very much importance. You might have heard that, and that's why we started this study when I was doing my MTech. Next one. This is the location where I have carried out this study in Uttarakhand. You might have heard about this particular area. Have you heard about Uttarakhand? Okay. So half of Uttarakhand is having very rugged terrain of Himalayas, lower Himalayas and middle Himalayas. And this is Alaknanda River is one of the small tributaries of Ganga River. Okay, where it joins to Ganga later. You might have heard about different holy places, and Alaknanda is one of the areas where many of the tourists they go. Recently, there was disaster in Uttarakhand 2 years back. Do you know that? What was that? Sorry? Kedarnath, right? Kedarnath. So this area is very close to Kedarnath. The second important place that is Badrinath, right? So Badrinath is in the study area. So this particular area just towards the west of Badrinath. Okay, let's go. This is the topographic map that will show you certain part of the study area. This one. The lower part of the glacier that is identified through survey and satellite topography and satellite images. Next one. Okay, I already told this. Next. This is the scenario, real scenario, photographs taken from the field. Now, on the left hand side, there is Satapal Glacier. On the right hand side, this Bhagirath Glacier. You will not see the ice open. Okay? It is covered with the debris. I'll show some of the photographs. These are the moraines, etc. you have studied in first year BA BSc, right? Geomorphology. This is Google Earth image, and from Google Earth also you can use Google Earth to demarcate the area. Of course, this is very rough. If you go in the field, then you can check the actual position. Next one. In this way, you can demarcate the boundary of the study area. Next. That is also application of satellite images. Sometimes you'll find that satellite images can be used to find out the area of interest, demarcation of the area. Okay? Because entire area cannot be seen. How to push it? Sometimes you'll not get to push it. It's better to demarcate the area from the satellite images. So these are the glaciers, two glaciers, like Badrinath, Badrinath and Mana village. Okay. From Badrinath, you have to walk down and climb at least for 14, 15 kilometers. Very rough condition, very harsh conditions. And then you'll be able to reach to the that particular area. Next one, please. This is inverted image. Why the image is inverted? Could you make the difference? Go back and forth. This one, the same image, inverted. What is the difference between? Not changing the direction. What is the difference between? This is actual. Sorry, go back. Now we check the glaciers. These are the valley glaciers. Valley glaciers are at the bottom of the valley. Okay. The lines which are joined like a fork. Okay. This is valley glacier. Now go to the next slide. Now it is looking at the valley. Actual perception or vision. This now you can identify the valley. In previous it was on the top of the valley. Something like that. The vision. So if you have to check the satellite images, you have to just turn around the satellite image and then you can get the 3D perception of that. Okay. Next. This is the same area as the curtain map by using digital elevation model. Next, please. Digital elevation model is also a product of satellite data. Sometimes people say it is not satellite image, but this is satellite data. Through satellites, you will get the digital elevation. And by using that, you can do such kind of maps. That is also an application of digital elevation model. Next one. This aspect map, aspect will give you direction of the slope at that particular location. This will help particularly in such areas where the slopes are exposed to sunlight, direct sunlight. Now, if the valley is oriented east-west, then most of the time in the day, sunlight will reach up to the valley base. This helps to increase the temperature. Please note that if the valley is north-south, then at very limited time, the surface of the valley will be exposed to the sunlight. That orientation of the valley is also important. So that is going to help us to understand how the exposure is important. Next one. These are the data sources. It is not required. This is the method. I use NDWI, NDVI, NDSI. These are the indices. By using satellite images and different bands, you can use such kind of indices. I will not go into technical details. Next. Same thing again. TM2 is thematic mapper tool. Landsat images are used. Then different bands are used. Within the Landsat images, there are different bands, and their ratio is used. Okay. Next. Field observations. Next. Okay. So this is end of the glacier, valley glacier. There are different cross sections by using dale. Now, what is the difference here? As you go downstream, away from the glacier, the valley width increases. Valley width increases. Just the valley. The shape changes. Now we have studied in literature that glacial valleys are U-shaped valleys. Yes or no? You can check that. That means up to there was glacier in the past. Currently there is no ice. This is the end. Okay. The bright part, that is the end of the glaciers. Now, but just below that, it is quite wide, U shape. If you go further down, the U shape is changed, deformed, because material from the tributaries is added. So you will not get actual emission. The material is deposited at the base of the valley. Okay, so that has changed. And finally, towards the end of this valley, Glacial Valley, near Badrinath, Manavidal, you will find the valley, this valley shape is totally changed. At the lowest part, there is a flow of water. But initial valley shows it is U-shaped. So basically, up to that level, there was valley glacier. Now it has gone back to 7 8 kilometers. That is the indicator of the change in the climatic conditions. Let's see. Again, the same thing. You can see the partial part in the lower map. Okay, next one. These are the depositions I was talking about. Would not only the tributaries, but because of the slow movement, the material comes down to the land. Actual flow is very narrow. And these are the deposits. Yusuf Valley has been modified because of these debris deposits. Okay? And how these deposits are there? Because of the geomorphic processes. And why the processes are there? Because of the change in condition, climatic conditions. Okay? Next one. This is mixed with tributary of the glacier. It is very small map, but it is bringing down very large material, which is not possible by a very small glacial tributary. Next one, please. These are the moraines which you have studied in the literature. Lateral moraines. And lateral moraines are getting eroded. Erosion is possible because of running water. Okay. So if the running water is more, that means temperature is low. Because melting of ice or melting of snow is there. And that causes erosion. Rings are formed on the moraines. Next one, please. These are the wheels on the moraines. It is clear indication of movement of water. It is not because of ice. So why water is moving? Because it is melting. Why it is melting? Because temperature is low. Next one. Next one, please. Yes, this is actual end of the snout. Actual end of the snout. Now we never expected that there will be vegetation at the end of just below the snout. Snout is what? The end of the glacier here. Okay? And just at the bottom of the snout, there are lakes. Some of the areas are totally dry. Water has been drained out, and around that you find vegetation. Now the quantity of vegetation at this position is increasing. Meaning what? The temperature at that location is becoming suitable for the growth of vegetation. Otherwise, in cold deserts, there is no vegetation, right? The canopy or bushes are increasing. That's why we have used NDVI to identify the changes in the suitable conditions. Next one. I'll take maybe few minutes, maybe 5 more minutes and then next. Indicators of landscape change. Already we have discussed them. Next one, please. Yes, this is what is the marking of this now or glacier. The northern one is Bhagirath, southern one is Satapattis. Okay. Can you demarcate these glaciers? Then you will find the position of snout. Snout position in 1990 and 99. I could do this because of the satellite image. Because maps, topographic maps are not available for these years. So it is possible to detect the changes only because of satellite images. So you can use multiple satellite images to find out the changes taking place over the period of time. So 1990 and 99. I could not get 2000, that's why I used 99. Okay. So you can see the changes. These are very minor changes, maybe few meters. So if you actually find out the area, then only it is possible. Next one. This is for 99 and 2000. I have overlapped two images. So you find the variation in the line. One is blue, other one is red. Very minor changes. Next one. So this is from 1990, 1999, and 2009. So over the period of time, how the glaciers have changed. Snout position. That will show you the melting of glacier. Next. Yes, this is comparison snout position in 1999 and 1999 2009. We'll see some of the areas have gone back, okay, and melting has been taken place at the time. This is the analysis of the same position, and final rate we got average change in year, that is minus 2.1 and minus 6.8 meters per year. That has been compared with the other studies. It is slightly lower than other studies. Next one. Minus is retreat. Please note that minus is going back, plus is advancing. So this is snow cover that we have done by using NDSI index, using two bands, and snow cover has been identified. Okay. Permanent snow cover. Next one. Snow cover map for 2009. So for these 3 years we have done. Next one. The total of snow cover in different parts of the valley, so to come left valley, right valley. These are the names given for the sake of identification. Next. This is change in the snow cover over the period of time and in different parts. Next. Very quickly. These are the sites for snow cover change. We have detected some of the sites, and the points are placed there to identify the variation in the reflectors. Yes. NDVI, this is black and white because it is racial. It is black and white, then you can give the colors. NDVI is vegetation index. Please note. Wherever there is a snow, there is no brightness. This is valley glacier. In valley glacier, there is no vegetation. Okay, but at the end of that valley glacier, towards the right hand side, you get very bright part. The entire valley is having very bright. That is an indication of increasing vegetation. So if you compare 1990 and 99, vegetation has been increased. Okay. Of course, it takes other parameters also like temperature of that particular day, particular season, and moisture availability. Next one, please. This is 2009. The brightness has been increased in 2009. Next. These are the sites where we have selected vegetation samples. Next. And spatial profile. That is for the NDVI. And we find the change over the value. That can be seen. Next one. This is increment in NDVI for different years. NDVI values are increased. This is between -1 to +1. The ratio, since it is ratio, it is always in the range of -1 to +1. That's why the values are very low. These are the supraglacial lakes. Supraglacial lakes are the lakes which are actually formed over the valley glacier. The valley glacier moves. If it is melted over here, you find the lake, small lake. Okay, like suppose this is valley glacier, okay, and if it is melted from the top, you'll find the lake formed. Now this lake also moves along with the valley glacier. That's why it's called supraglacial. Okay. Number of lakes have increased. That means more water has been formed because of melting over the period of time. So the basis we have taken it was 1962 black, and we could identify blue spots on the glacial valley. I don't know whether these are visible to you or not, but I have highlighted one part. These are all supraglacial lakes. Actually, next. These are identified through NDVI and NDWI. And then it is compared. The total number of lakes, their areas are calculated. Okay. Next one. So what we found, NDVI values have changed. NDVI can be used for water bodies also. Okay. The values have changed. Next. This is movement of the glacier. Two cartosat images are used. Cartosat image is having spatial resolution of 2.5 meter. Any object greater than 2.5 meter can be identified. So you can see the dark patches. These are the super glacier layers because of melting. And these are the chiplet in image 1 2006 and image 2 2008. Right? So that is identified. The distance is calculated divided by years. Number one. Next. The total was 34 point, almost 35 meters. The movement of glaciers during 2006 and 2007. That is identified. This is okay, ice age. This is not required actually, but you can see the variation in the level of glaciers present in the past, present and in the past. This is what we have done to identify the ice age or last ice age line. Next, next. Okay, just put the previous one. Previous one. Yes. If you look at this line on mark on the valley glaciers, on the other side there is Gangotri, on the opposite side, left hand side. Okay. So the records from the Gangotri glacier of the last ice age and the records from Alaknanda Valley are matched. The level is matched. This is what is the outcome of this study. Next one. Next. I think we are not interested in the numbers and these figures, so I'll start. Next. Yes, next one. And I think that is the last. Thank you very much. I hope I am giving time. It took more than 1 hour. 1 hour, 3 minutes. Any question or anything to ask? Since you are from geography and other branches of science, anyone from arts, other subjects of arts, other than geography? I mean, geography is both science and arts. Since you have selected this particular subject as the option of your career, you have to be very patient. Since because you have to go into the field, you have to do lots of things. Right? Even the other branches of science, if you are working in the laboratory, you have to be very patient to get the results. Sometimes you get the failure. Any question? Any question? Yes, please.
सर तुम्ही सांगितलं की आपण कॅमेरा जेव्हा यूज करतो डे टाइम मध्ये तर फ्लॅशची आपल्याला गरज नाही पडत नाईट मध्ये जेव्हा आपण कॅमेराचा यूज करतो तर फ्लॅशची गरज पडते सेम सॅटेलाइट मध्ये जेव्हा आपण डे मध्ये यूज करतो तर लाईट आपल्याला भेटत जातं इन सोलर रेडिएशन तर नाईटच्या टाइमला आपण फ्लॅशच्या जागेवरती काय यूज करतो सॅटेलाइट
See, these satellites, polar orbiting satellites or synchronous satellites, they work only when they are on the same side, I mean towards the side of the sun. When they go to the other side, there is a light. Okay, so they don't work. Passive remote sensing satellites don't work. So they always record in descending mode. Suppose this is sun, this is earth, the satellite is here. So the light from the sun will fall here, it will be recorded by the sun. The earth is rotating, right? So every time the satellite moves, so on one side the earth is rotating, the satellite is changing the track with the rotation of the earth. So this angle is maintained. You got my point? When it goes down, it records. It senses the earth surface. On the opposite side, there is no light. It is a night time. So it doesn't record. So it comes here and then it starts recording. Okay. So So for passive sensors, there is no such you know, facility available. But it can be done on the same satellite platform. You can use active sensors also. When it is towards the sat, it will use passive energy. When it is on the opposite side, it can use active, like radar. It can. Any other question?
So you mentioned that 25 centimeter also object can be detected with the infrared sensor. So my question is like, can we detect a bomb?
Bomb. There are different detectors of the for the bomb, like metal detectors. There are other nowadays. Sometimes it is plastic bomb, then metal detector will not work. And people they are very much clever. They are using different material so that they can hide the bomb. But the sleeper dogs are there. If you are having problems, because this is very local. Whatever there is below the surface cannot be detected by satellite sensors in passive remote sensing. In active remote sensing, yes. But there is limitation. Like up to certain depth, radar or microwaves can penetrate through the ground. It is having the ability to detect the surface, but even today we have the technology that will mislead the radar energy, radiation. Like we have still aeroplanes, fighter planes. Have you heard? Still, that will not be detected through the radar. Such kind of giant object that is not detected. So detecting bomb will be a problem. But there are other sensors also which can be used.
So what are the career opportunities in remote sensing?
Yes, yes. Obviously, there is no career opportunity. I used to tell the students there is no career opportunity. You have to create the opportunity. Unless and until you have something in you, nobody will ask you, right? You have to prove yourself in that particular field. Then everyone will follow you. I'll give you one example. Maybe Aniket sir is aware of that. One of our students is from Civil Passive, MA Geography. Play. He has done certain course. His name is Goran Dhawde. From the name also you can identify, I mean you can judge. Goran Dhawde, right? He has done special only MA Geography, right? And he has done some course in Goran. Now he is giving training to engineering students. Can you believe that? And he is posted in Australia. Because he proved that he can do HGIS. It is up to the student, up to the person. After taking MTech degree, many of my friends, graduates, they ask me, are you going to leave this job or are you going to somewhere else in PC or other organization where it will pay very high? I said, no. I said, no. Because I don't want to prove. Right? I have to use this technique in my research or in my career. But if you have the ability to prove yourself in private sector, it is the most important. That you have to prove yourself. Then only it will be paid very high. Second example, I'll give Vinit Bitla. Vinit Bitla recently we had arranged their lecture, MA Geography, and 10 months course in informatics. Now he is paid by HSBC. Have you heard HSBC? HSBC Bank. Okay. How much is getting? 35 lakh per annum in corporate sector. Before that, he was in John Deere and other companies. He is just after the experience of 10 years, he is earning now 25 lakhs per annum. Even we are not having that salary. It is up to you. I mean, there are hundreds of career opportunities. I won't say everyone will get job. No, I will say no one will get the job. Why? Because you are just learning, giving the exam, passing, getting the certificate, and showing the certificate to others. These are the fields where you have to prove, you have to do it practically. If you are having knowledge, you have to apply it. Then only it is possible. Otherwise, no. No such a field available nowadays where they will see your mark is, oh, you got 90%. Come with us. No. Nothing is like that. So there are no opportunities for the student those who are just taking the certificate. म्हणून सांगतो की तुम्हाला प्रत्येक ठिकाणी प्रूव्ह करायला लागतं बरोबर ना भूक लागली हे सांगितल्यावरच आई जेवण देते बरोबर बरोबर ना तसंच तुम्हाला प्रूव्ह करायला लागतं there are opportunities of course if you are taking training in this field chances are low chances in the field of remote sensing and JS are low. Like if you are having only teaching job, then the chances are less. Any other question? Yes, accuracy percentage. Obviously, there are errors because the exam system works with very different conditions. You know, if this satellite is sent in the space, there are different problems also. Sometimes the satellite leaves the track. If this is the decided track, there is no control, there is no driver or no pilot, right? So we have to think about the errors which are the possible errors. If the satellite moves here and there, up and down, definitely there will be error. That is called geometric error. If the sensor is not working, like you have LED panel, maybe one or two LEDs are not working, so you will not get the desired intensity of light. Similarly, the sensors, there are different CCDs, charged coupled devices, like your LED panel. So these CCDs are looking at one particular area. If any one of these is not working or not properly working, though it is working, but the say sensing the light is not proper. Sometimes it is sensing less light or more brightness. Okay, that is possible. So that is also a source of error. There are different sources of errors. But overall accuracy of these satellite data sets for problem people, that is about 1 to 2 meters. I mean error. Error is 1 to 2 meters. It is highly accurate. Depending on the GCPs, you have to collect the ground control files. Then you have to re-register the image. Then it becomes very accurate. Depending on the GCPs, you can do better. Images in the mountainous regions like Himalayas will have little more problems, errors, because of the geographic effects. Any question? Have you understood whatever I have discussed in the class? Am I successful to deliver? Thank you very much.
On behalf of our college, I extend a hearty vote of thanks to our chief guest, Dr. Sudhakar Pradeshi sir, who spared time and graced this occasion. Today, we had an opportunity to hear your thoughts, and this has surely enhanced our knowledge. Thank you, sir.
A special mention to our respected principal, vice principal, HOD, and staff members for being the catalyst that stimulated us to do our best, standing as the pillars of strength with deep sense of appreciation. We thank our teachers for their untiring efforts. I would also like to thank our Professor Samir Narlekar sir for technical support. Thank you, sir. We can't see satellites actually working for remote sensing, but tomorrow we'll be seeing drones in the skies of our college, how drone survey is done, and much more. So please do attend tomorrow's special event too.
I would like to thank the people who worked behind the scene to make this event happen. Finally, I would like to thank our budding rock stars that made this event successful. Once again, we thank you all.